Hi all, welcome to Learn Code Repeat. So today we'll be looking at binary search algorithm. This is one of the easy search algorithm. Let's look into the algorithm. So binary search allows you to search a given number in an array in efficient manner. So the time complexity of binary search is normally log of n, and we'll see why it is log of n. So first, before going into binary search, let's see in a brute force manner how you normally search for a number in an array, right? So let's say we have an array of sorted ascending numbers. So this is the array that we have from 0 to 9. This is the index number, the one in yellow, and the values are in white, and we have to search 15 in our array. If the number is present, we have to return the index, else we have to return -1. Okay. Now in a brute force approach, we normally would do is we'll go through each and every element in the array and compare with the target number. So here our target is 15, so we have to check whether 15 is present or not. So we'll go to 0th index, check whether the number is 15, no, then go to the next index and so on until we find 15. Now here if I find 15, then I will return 3 as the index. The other case can be that I am searching for, let's say, 60. Now 60 is not present in the array, but still I will have to go through each and every element, right? So I will go through 0, 1, 2, 3 like that till 50, and I won't find 60, so I have to return -1. Okay. So in that case, the complexity of this algorithm will be O of n. So brute force complexity is time complexity is equal to O of n, right? Because we have to go through each and every element in the array. Now can we improve the time complexity here, right? So that's where binary search algorithm comes into picture. So binary search algorithm can only be performed if the array is sorted either in ascending or in descending. So that is the important precondition for binary search. Okay. Here since the array is sorted, if you have to find 15, right? 15 is here at this position, right? So what binary search algorithm says is divide the array into two halves and then compare the mid value with the target number, and based on that you can either go to the left or to the right of the array. Okay. So what does it mean, right? So these are the three steps. Find the mid value. Okay. So the first step is find the mid value. So what is the mid value? So let's say this is my low index and this is my high index. Okay. My high index is 9, my low index is 0. So high is basically the length of the array -1 in terms of index, because it's a 0th index, so length -1. So length is 10, 10 minus 1 is 9. So high is 9 and low is 0, right? So to find out the mid of that, we normally would do is mid equal to low plus high divided by 2. This is the normal mathematical formula, right? So this will give me 0 plus 9 divided by 2. So the integer value will be 4. So fourth index will be my mid, right? Now ideally we won't use this formula, instead we would use the formula as mid equal to low plus high minus low by 2. The reason why we use this formula is because if integer is max value, right, so that means my high is near to my integer dot max value. So low plus high will create a condition where my integer may go beyond the integer max value. So this may not give me the correct output if my numbers or my array is a huge array, right? So to avoid that, as a best practice, we normally use low plus high minus low by 2. So what will this give, right? High is 9, low is 0. So high minus low will be 9 and this will be 9 by 2. So 9 by 2 is 4 and low is 0. So 0 plus 4 is 4. So this also gives the same result. So in both the cases the result will be same. So this is same as if I evaluate, this will be 2 low plus high minus low the whole by 2, right, which is nothing but, so 2 low minus low is low plus high by 2, which is same as this, right? So it evaluates to the same thing. So by doing this, what we are doing is we are not adding low to the high directly, we are instead subtracting low from high, so high minus low. So this will make sure that my int value doesn't go beyond the integer range, and then we are dividing it by 2 and then we are adding it to low. Okay. So this is just a side note on the formula that we will use for mid. Okay. Let me remove the other formula. So now we know how to calculate mid. Now let us see, once we get the mid value, right, what can we check. Now what we are saying is, as part of binary search algorithm, if the mid value is same as target, my target was 15. So first I will check whether the mid value, my mid is 4, so the value of fourth index is 17, whether 17 is same as 15, no. So here it says if it is same, then return that index. So obviously we will return that index if it is same, right, but in this case it is not same. So what should we do when it is not same? So if the mid value is less than target, right. Now since the array is sorted ascending order, so we know the values to the right of my mid is always greater than my mid, right. It will never be less than my mid because this is sorted ascending order, so it will be always greater than my mid. So I can check whether the value I am searching for, whether it is greater than or whether it is less than mid, right. So if it is less than mid, that means that value will always be on the left side of the mid, right, and if it is greater than mid, it will always be on the right side, right. In this case 15 is less than mid, so it will be on the left side of mid, right. So it says if the mid value is less than the target, continue search in the right side. Ours is not the case, ours is the third case. If the mid value is more than the target, continue search in the left side. So we have to continue search on the left side. So that means we do not have to look into the right side at all after this step, right. So in the first step itself, we are removing almost half of the array, right. We are basically ignoring half of the array itself, and we will not be looking at this part at all. So already it is n by 2 algorithm, right. Now again let us see, once we know that we have to go to the left, after that what should we do? So once we know that we have to go to the left, after that we have to, since my high was here, right, my high pointer was here, I have to now change my high pointer, right, because we are going to ignore this part, the right part. So my high pointer now should point to, it can either point to this mid part or it can point to mid minus 1. But why would we go to mid if we know that my target that I am searching for is not at the mid, right. So I do not have to point my high pointer to mid at all. So I can directly say that my high is mid minus 1. I can directly place my high here, right. So I will place my high here at mid minus 1, and then again I will find out what is my mid with this new high and low pointer, right. So again my high is 3, so using this formula 3 minus low is 0, so 3 minus 0 is 3, 3 by 2 is 1, low is again 0, so 0 plus 1 is 1, so my mid becomes this 1, okay. So this is my new mid, let me remove this. So this is my new mid, okay. So now my range is from 0th index to 3rd index, that is my range. Now again I will compare this target value with my mid. So the value at mid is 10. So my, again using this logic, my target is greater than my mid value. So here it says if the mid value is less than the target, that is what happening here, my mid value is 10 and that is less than my target. In that case continue search on the right side. So I will continue search on the right side of the range. Now my range is only from 0 to 3rd index, right, from low to high, that is my range. I am not considering any of these things, right, on the right hand side. So only this is my range. So when I say continue search on the right side, it means on the right side of mid now it is 2nd index and 3rd index, right. So when I am continuing on the right side, that means the left side of mid I should ignore, I should totally ignore. So I can totally ignore this part on the left side, but if I am ignoring this part, then I need to also move my low pointer, right. So in this case low pointer, since we know mid is not equal to target, like the way we did for high, we can say low pointer is mid plus 1. I can directly place my low pointer here, right. So I will remove this low, I will remove this mid as well, because now I need to recalculate my mid because the low pointer has changed now, right. So my mid now will become high minus low is 3 minus 2 is 1, 1 by 2 is 0 and low is currently 2. So 2 plus 0 is 2. So my mid is now same as low, okay. Mid is also pointing to 2. So at this point I will again check whether my target number 15 is same as 12. It is not same, rather my mid is less than 15. So again I need to go to right. Okay. So again I will do low is equal to mid plus 1. So my low now will become 3 and this will get cancelled off and I need to ignore this part. Okay. So now my low and high both are at the same index. Okay. Now when this low and high is at the same index, at that time if I calculate my mid, right, it will be high minus low will give me 0 and low is index 3. So low plus, so 3 plus 0 will be again 3. So mid will also point to the same index. When mid points to the same index, at that time when I am comparing with the target number, it will find that the same number matches and it will return me 3, right. So we went through the loop until low was less than or equal to high. Okay. And if you observe, we did not go through each and every number. The comparison that we did was only 3 times, right. One was here mid, second was here 2 and third was here, and the fourth time was when we got the number, right. At that time it was mid was here, right. So in total we did only 4 comparison. That means we went through the loop only 4 times and the total number of values in the array was 10, right. So every time we were dividing the array, right. So basically if you see, this is similar to a log of n operation. Whenever we are dividing a range of numbers into half of its sides at each step, that is same as logarithmic operation. So that is why the complexity of binary search is logarithmic. Now since the decision that we are taking whether to go left and right, we can take that only because we know that the number to the right will always be greater than my mid number and the number to the left will always be less than my mid number, and that is because the numbers are in ascending or descending order, right. It can be either ascending or it can be either descending, right. So basically it needs to be sorted order. So that is the reason why binary search algorithm has a precondition that the arrays should always be in sorted order. Okay, so hope you got the algorithm. We will check one more example where we are not able to find the number. So let us say instead of 15, right, we have to find 60, right. 60 is the number that we have to find, right. So again my mid will be, first I will start with my mid as 4. Okay. I will compare the value at mid, which is 17, to 60, right. Now the value at mid is less than 60. So I know the value 60 if present in the array, it should be on the right hand side only, right. So I can ignore the left side of the array. So I will ignore the left side and it should be on the right side. So earlier low was here and high was here. Now the low will come to mid plus 1, right, and my mid will now be different mid, right. I need to calculate the mid again. So now the mid will be high minus low, which is 9 minus 5 is 4, 4 by 2 is 2, low is again 5, 5 plus 2 is 7. So 7th index will be my mid. This is my new mid. Again I will compare it with the number that I need to search, which is 60. So 26 is less than 60. So again I know that 60 if present in the array, it should be on the right side. So I can ignore the left part of the array and also this part. So my low will again be mid plus 1. So my low will come here. Now again I need to recalculate my mid. So mid will be 9 minus 8, high minus low is 9 minus 8 by 2, which is 1 by 2, which is 0, and low is 8. So 8 plus 0 is 8. So my mid is now also pointing to 8. So low and mid is same. Again I will check whether the value at mid, which is 40, is same as 60, which is not, rather 40 is less than 60. So I know I need to move again right. So this will be ignored and low will be mid plus 1. So mid plus 1 is this. So now low and high is same. I need to again recalculate mid. So mid will be high minus low, this will give me 0, low is 9. So mid will also be 9. So all high, mid and low is pointing to the same index 9. So when I am comparing my mid value with the target number 60, I see that mid value is less than 60. So again the target number has to be on the right side, right. And if we follow the same formula that we did earlier, so now low should be mid plus 1. Okay. So if I do low is mid plus 1, low will come to this part, right. But our array is ending here, right? So low will go out of bound, right? So in that case we are not able to find 60, so we have to return -1. Okay. So our condition should be, because when low crosses high, right, at that time low comes here, right. So our condition should be low should be always less than or equal to high. As soon as it crosses high, that means we are not able to find the number. Okay. So let us see the pseudocode for this. So this is a pseudocode. Low initially is 0, high is length of the nums array -1. -1 we are doing because it is 0th index array, so that is why -1. And in the while condition we are checking whether low is less than or equal to high. Only till that point we have to go through the while loop. If we are coming out of the while loop, that means we have to return -1, because we did not find any number that is matching. Because if we would have found the number, then at this point we would have returned the index of that number. Okay. So here I am doing the mid, so I am using the same formula here, low plus high minus low by 2, and first I am checking if the nums at mid is same as target, then return the mid. If that is not the case, then check whether it is less than or whether it is greater than, and accordingly move the pointer for low and high. So if the nums of mid is less than target, then low should be mid plus 1, else my high should be mid minus 1. So the way we did in the example earlier, we are moving the pointer here accordingly, the same logic. Okay. So this is a simple logic for a binary search, and as I said, since at each step we are dividing the array into half, right, so the time complexity of this will be O of log n. Okay. And since we are not using any additional space, the space complexity is O of 1. Okay. The only precondition, as I said, is that your nums array on which you are doing the binary search should be sorted. It should be either sorted ascending or it should be sorted descending. If it is sorted descending, then this condition will change, because the left and right will be opposite direction. So this less than will become greater than in that case, else it will remain same. Okay. So hope you like the video. If you have any questions, please do write into the comment section, and do subscribe to this channel. Thank you.